Okay, I suggest that we get started um, with my half of the slot, which is about protecting hosts in IPv6 networks, as opposed to like infrastructure level controls I mainly discussed in my yesterday's talk. Before I get into this, I'd like to add an anecdote to what Ivan just mentioned. We have a customer, quite large organization, which actually started their IPv6 project quite early in 2012. It's an enterprise organization, and they had an ambitious roadmap of having all their internet-facing systems in the main regions, Europe. Ich bin näher dran, aber das geht irgendwie nicht. Keine Ahnung, wie sollte ich das näher dran bringen? Ja? Andere Ohr. Ich habe ja zwei. Also, andere Ohr so. Aber Gott sei Dank haben wir eine Minute, die wir für sowas verbrauchen. Ist jetzt besser? Wie war das mit dem Star Wars Intro? Was ich zitieren soll? Also ich lasse es jetzt so. So, mehr mache ich jetzt nicht. Star Wars Intro kann ich auch nicht. Getting back to this anecdote, and actually at the end of, I think that must have been 2000. It was like 30th of, no, it was end of 2013, I think. They reached this point. So they're like all web servers, MXs, DNS firewalls, load balancers, whatsoever were dual stacked. And from that angle, they were like, okay, whoa, we got this project phase done. And kept on, they moved on to enabling IPv6 on the network infrastructure, which was, if I recall correctly, I was actually involved in writing the roadmap until end of 2016. Point is, last year we were tasked to perform an IPv6 pen test for them. Like IPv6 pen test usually means perform a pen test with specific focus on properties of IPv6, like can you evade the IDPS systems by means of extension headers? What about, is the security posture over v6 the same as over v4? Like, can you reach different services? Is there any particular ports which are open over v6 and not over v4, or vice versa? Things like this. And as part of this pen test, it turned out that SMTP, TCP port 25, was not reachable over IPv6. And we were like, wait a second, is this intended behavior? And it turned out on their main, the external layer of mail exchanges running, in that case, postfix, the daemon wasn't listening on v6. And for nearly 2 years, nobody has ever noticed that one of the core services, which was supposed to be reachable over v6, wasn't, due to the simple lack of a certain configuration. So this probably goes along with what Ivan said. Just like enabling v6 or in a dual stack setting doesn't mean everything works properly, and you might not be able to notice as long as you just like do stuff like pinging or testing if. Do we notice anything going wrong? No, we don't. So probably it's fine, and maybe it's not when it comes to v6. That said, let's get back to my thing here. What I'm going to discuss in this talk is split into 3 main pieces. First, I'd like to give some remarks on an operations perspective. This will be important for the second part, or for the following parts of the talk, which are on actual controls. But before we tackle those controls, given I have a background myself in large-scale operations in the 90s, I was involved in several carriers. I was involved in running the network of the Expo 2000 in Hanover, stuff like this. So whatever happens, I always try to, when looking at security controls, to keep an eye on the operational perspective. And there are some things I'd like to discuss from this angle before I actually discuss IPv6 specific controls. When, say, asking somebody who's involved in security in a sufficiently large organization of like, what do you have? What elements do you have in your IT environment which contribute to security? You usually get answers, okay, like we have firewalls, we might have antivirus, we have processors like patching, we have ACLs on routers, but we might have access control mechanisms on our Unix servers as well. When like trying to group those things, all these elements which contribute to security, there is two main approaches. One is you can group all the security controls along, say, their main mode of protection, which could be like preventative controls, prevent bad stuff from happening, as opposed to detective, like note when something bad has happened, and reactive, react on either something bad has happened or I learned something new about the world. So detective reactive controls. For example, just a simple example, patch management by itself is a reactive control. You learn that in the world, well, your technical item hasn't changed, but your knowledge about the world. Oh, this item has a vulnerability. I know this since yesterday, and I react on this newly gained knowledge. So this preventative versus detective and reactive controls is one potential approach of grouping all the security mechanisms that you have. Another one that is laid out here is you can classify whatever you have security-wise into, like, there is stuff you can actually touch. You can buy boxes, firewalls, appliances, for just as an example. A second, there is like rules or the way how these boxes are actually configured. On a Unix file system, the say ACLs or like flags displaying who can access what is such a piece, and staying in the realm of a firewall. A firewall rule is such a piece. And then there is a third pillar, which is operations. How you actually operate your stuff. What about your processes? Change management, log analysis, incident management, user account management, all this stuff around actually operating data security or operating in a way that contributes to security, either in a good way or in a bad way. A rhetorical question at this point could be, which pillar do you think is the most important one? I won't do this right now, but my hopes, I do sincerely hope pretty much everybody would raise his hand. This one is the most important one. It's not about like if you buy a green or red or blue box, and okay, there might be some influence for your overall security posture, how this stuff is initially configured or is configured at a certain point of time. But in the end of the day, I can firmly state this, given I'm in the security area since like 18 years and like 15 years of those in security assessments. Looking at something from a perspective, is it secure? How does it contribute to security? So within with a certain say reviewer's perspective, I can, one of the lessons we really learned is operations is key. So keeping this in mind, this means whenever we discuss a security control, potential thing that can be done for securing something, we should not just discuss, okay, how much does this contribute to actual security? If I buy this, or if I change a parameter, or if I perform, once I perform a certain configuration, how much does this help security-wise? We must, and I mean this is probably a no-brainer, and I apologize in advance if I tell you things that you already know and have deeply in your heart. You must think about what is the operational price, what is the operational effort or impact of this set control. Well, simply as keeping this in mind. This is where, I was looking for this yesterday, wo die Musik spielt, where the rubber hits the, thank you, where the rubber hits the road, that's this one. So, thinking about security controls, and I'll be finished with this introductory notes very soon. Means not just look, okay, how much, is there any ideally positive security impact of a certain configuration step? But what is the operational price tag of this exact configuration step? And this, so not just looking at the security benefit, but also at what we call the operational feasibility. How easy is it to implement a certain security control? To understand how, to count or to be able to evaluate this operational feasibility, it could make sense. And this is probably very familiar with along the lines of Ivan's talk. You could look, okay, how much configuration steps, how much lines of code or configuration do I need to implement something? Can this be automated, or does this differ between in different settings? A very simple example I like to give in this context is, imagine you have a set of routers and you want to secure the exchange between those routers, like a backbone that's running a routing protocol. There was a Cisco guide from the Cisco Safe initiative 10 years ago, which actually, amongst others, suggested a configuration of what they called static peers. That is, instead of run your routing protocol in a multicast shared network mode, configure this router just to accept routing updates from these three. Configure this one in a way okay, you only accept routing updates from this one, and this one. You get the idea. This concept of static peers is, when you look at it from an operations perspective, this is hilarious. It actually means on 4 devices you have 4 different configurations, like router A except from B, C, and D, router B except from A, B, and D, and so on. Whereas if you had an approach of securing the routing protocol by means of a shared authenticator, then you have the same configuration on all of those. This is one of the things that come into the equation when looking at operational feasibility. How good can I automate? How much additional steps are needed to do something? To what degree, do I need additional steps in doing something, or do I need supporting processes? All this should be taken into account when looking at this benefit, security, and a cost ratio, where cost means operational cost. Why do I tell you all this? This will play a large role for the steps we will discuss in the following. Before I do so, one additional term or concept I'd like to introduce that we used extensively in one of the main environments I was working at 10, 15 years ago. That's the concept of deviation from default. Deviation from default essentially means changing something from a default state. You have a number of systems running a daemon, and in the config file of this daemon, a certain parameter is either there's a comment, or so it's not activated, or it's set to a 0. And for whatever reason, you decide, okay, in my environment, it would make sense not to go with a 0 here, but with a 1. At a first glance, this might sound simple. It becomes interesting once you have different versions of this daemon running, which has different configuration files. It becomes interesting once you perform like the next system upgrade resets it back to 0. It becomes interesting once an auditor comes into your environment and you explain, wait, part of our security model is we go with a 1 at this parameter, do not enable root login, say in a SSHD config. This auditor asks you, well, are you sure you have this on all your systems in the data center? You're like, well, I don't really know. It's part of our templates, but it might have been changed either by human intervention, either by like a system upgrade, kernel recompilation, whatever. Deviation from default essentially means you use something in a way that is not how it is shipped. There will be, some of you will already probably recognize what this might mean in the IPv6 space. At a first glance, this may look simple. From an operations perspective, once you have to maintain a deviation from default during a whole system life cycle and in a heterogeneous environment, it might become an operational nightmare, which is, in short, why deviation from default, operations-wise, usually is considered a bad thing. So now, all this said, let's look at what you usually have in your, say, toolbox when it comes to IPv6 security on the system level, as opposed to the network level. Network level is the stuff we discussed yesterday: filtering, routing configuration, first-hop security. All this is infrastructure stuff. Now it's like, okay, you guys running the servers over there, is there anything you might need, or is there anything that you could do like to augment IPv6 security? Let's, for this discussion, take into account that stuff like the one we discussed yesterday has already been done. There is filtering in your network infrastructure. There is a certain way of how routing and address space is handled. And there might be first-hop security measures. From a sys owner's perspective, a server running in a data center, or a system like somewhere in the corporate LAN, there are two main questions. Is there anything else I have to do? What are the residual risks? If you network guys over there have done your homework, can I like relay? I mean, probably some of you might be aware that in your organizations, IPv6 is usually considered like a network topic. It's a network infrastructure guy taking care of this. Why did you bother me, application or like a server operator with IPv6? It's your task to secure this. By the way, and vendors have the same attitude. Microsoft, for example, has for a long time, they have declined doing anything in the IPv6 like security field, prevention against rogue router advertisements, crashing the system and stuff, as their stance usually was like, wait, Cisco must take care of this, not us. It's a network thing, which I even think there are some that might be considered a legitimate perspective. But back to this, what remains if the network guys have done their homework? What remains in a risk field, and what to do about this? Those of you who have been in my talk yesterday might remember there was this table with the risk rating in IPv4 networks, and then there was this, okay, what's the risk delta? How does IPv6 change certain types of threats? And I've modified this. Actually, this was done in a specific, this is from a case study, from a real-life organization. We had a look like, okay, once we have implemented certain stuff on the infrastructure level. Again, from a host perspective, what's left? Is there anything, what about the overall risk posture? And it turned out that in the end of the day, we identified some fields, that is, of course, rogue router advertisements. This is new in IPv6. This specific threat hasn't existed in IPv4. It's just for consistency, and it's in this table to have it here. Then there was like, okay, in this environment, we considered flooding of helper protocols. Helper protocols usually means those not or IPv6 protocols which are needed for operations. DHCP, MLD, in IPv4 ARP. There is even some people who say like SNMP is a helper protocol, but it's mostly like DHCP and MLD in the v6 world. And it was considered like the risk unauthorized access over network. Systems become reachable, which haven't been reachable before, due to changes to global addressing and maybe immature routing handling. And as in this specific organization, their security model heavily relied on IDPS systems, on being able to detect bad stuff, as opposed to prevent bad stuff. And they were of the opinion, well, the detection capabilities that we had in the v4 world will be, we will have less visibility in v6, which is why we consider that the risk of untrusted entities being able to establish connections to our to-be protected systems, or like to reach ports or something, actually that one will increase. These two were considered from again the host perspective, remaining risks. And then we tried to discuss, okay, what could we do to further strengthen the security posture of individual systems? And actually, we had where's Antonius? Oh, Antonius is probably over there in the other talk. Antonius has, well, we had developed together with, in collaboration with Antonius, but he was the main author, 3 hardening guides for IPv6 for 3 different operating systems, which is, wait a second, it's this one. That was the last one, which I consider not that important, but we have an IPv6 hardening guide for Linux servers. There is one for Windows servers, and upon request, there was a comment on the blog like, do you have such a document for OS X? We were like wondering, okay, how many people do use OS X in a data center? But, well, it was like in German you would say a Fingerübung, like a little nice exercise, okay, write this for OS X as well. But there is 2 documents which have been authored by Antonius and published in collaboration, which describes a number of very specific steps which can be done once you want to like harden IPv6 on a given system. The point about these, I won't go through all these measures. I will show some of them, as I will group them into several categories. It should be kept in mind here that these measures are like on a scale of fully tightened system, which is, I wouldn't say next to unusable, but which requires considerable operational effort, as opposed, that is, say, one end of a scale, whereas on the other end there would be like easy to operate, but not so secure, like in a default state. The stuff that is described in these hardening guides, and we made this very clear in the introduction of those documents, is for very specific use cases, high secure data centers where you are willing and able to put significant energy into operations. As a result, you will have highly secure systems, but you need to put, again, operational effort into this. For example, Antonius, amongst others, describes how you can configure static neighbor cache entries. So you want an attacker who gets access to such a segment won't be able to fiddle with neighbor solicitations and neighbor advertisements, so to perform ND spoofing. But probably some of you will already know it from an operations perspective. Going with static neighbor entries is not exactly maybe what you want in a sufficiently large environment. This is just to make clear, there is stuff described in those documents. Do not blindly, like, pick a document. Oh, this is hardened IPv6. Let's do this for our servers. If you listen carefully when I discuss the operational aspects. Still, looking at the measures which we have described in those documents, at the end of the day, they can be grouped into 4 main categories. The first one is what we call the traditional minimal machine approach. That is, disable stuff that you don't need. Service that's not running cannot be attacked. It's as simple as that, and probably, most people here in the room know this and maybe have configured their stuff in the past like this. I will discuss all of these in more detail in a second. Disable stuff that's not needed, minimal machine approach. Then there is this approach of, once you don't trust like the dynamic mechanisms, and the IPv6 world is full of dynamic mechanisms. The main IPv6 paradigm is being able to act in a mostly autonomous way. Internet of Things. Even though the term didn't exist like 20 years ago, many concepts of IPv6 particularly apply to the Internet of Things, where things operate without much human intervention, without much high degree of human control. So this is what is incorporated in IPv6. And now there is like human nature loves being in control. So I know that many of you probably have like, for our high secure servers, let's go with static addressing. So I really know what address they have, and I can put this into like firewall rules and stuff. Point is, this is really against the basic say architecture of IPv6, as we will see. But that is a group of steps you can take. Configure something in a static manner. Then the third group would be, again, this is all on the actual on a system level. The third group would be tweak some stuff, like modify timers, modify behavior of certain protocols, tuning in a sense. And the fourth one would be local packet filtering. Go with IPv6 tables, whatever, on your Linux servers in a data center to protect from bad stuff coming in over v6. We'll discuss this in a second. Let's start with the minimal machine approach. What reasonable measures can be done in this space? Please note that I explicitly added the term what reasonable measures. In those documents, we have laid out many, many things that you could do to have a fully hardened, very tight system, but requiring significant operational effort. What I focus on in this talk is what we usually think makes sense to do in a sufficiently large organization where operational resources don't scale infinitely. One thing that you could and actually should do on Linux system is disable MLD. except when you need it, but we can tell you in say 95% of our customer environments, MLD is not needed. Multicast listener discovery, that mechanism where systems in a segment can tell the router, oh, I'm interested in listening to the following multicast groups. Problem with this one, and I mentioned it yesterday, and we discussed this extensively last year in a talk that we gave at the IPv6 Summit. Depending on your interpretation of a certain RFC, people think that MLD is needed for neighbor discovery, which it is not. Our interpretation is it shouldn't be. But MLD runs on pretty much all operating systems by default. On Linux, you can disable it, and you should disable it. Windows, problem is, once you disable it, there is you can do that with netsh or netshell command. Neighbor discovery doesn't work any longer, which is bad. You don't want this. So on Windows, you can't disable it. What you can actually do is block it by means of the local firewall. So in fact, you don't need it. If you enable a Windows firewall and block MLD, nothing bad happens. Your network will continue to operate smoothly, except for if you really need MLD for multicast groups of whatever type. In case you don't, network will operate smoothly once you block it by packet filtering. If you disable it by this netsh command, actually ND won't work any longer. So for Windows, it's not an option. For Linux, it can and should be done. And actually, it's a good measure. Something that's not running cannot be attacked. I'm traditionally, I myself and we at ENW, we have always been fans of the minimal machine approach. Disable what you don't. Then in this space, what you could do is disabling DHCP, the DHCP service, or local DHCP daemon running. Of course, you can only do so if you either go with static addressing, or static, say, parameter provisioning. I wouldn't call it just addressing. Or once you go with Slack. Obviously, once you use DHCP-v6, you can't disable it. But I've been involved in a customer environment in a data center just recently, where they plan to provide addresses and stuff in a static manner to certain systems, and they want to avoid that these systems get additional addresses. And there is two actual mechanisms which they could get addresses from, which would be either Slack, say, preventing Slack, kind of easy, at least when it comes to preventing authorized Slack. That would be disable route advertisements on the layer 3 devices. But the thing is, it turned out they want to use the DHCP for specific systems, but not for the majority of systems. And then it turned out, some of you might know that Microsoft, since Windows 8 on the client and Windows Server 2012, the server, they do DHCP v6 even without being advised to do so by flags in a route advertisement. Windows systems of newer generations always try DHCP, even if in the router advertisements, the EM and the O flag are cleared. There's a number of people who consider this as a deviation from the standards, but well, it is what it is. And in that specific environment, there was huge discussions like, okay, we don't want these systems. We just want these systems, specific set of systems, to have a static address. We don't want them to interact with anything else. And the recommendation from Microsoft actually was, well, that's a problem. You cannot really. I mean, they have for v4. They use DHCP with reservations for this type of static what is called static DHCP in a number of environments. You use DHCP, but you always get a certain address by means of reservations, which some of you might know. Reservations in IPv6 is not easy. as there is an RFC 6939 which allows this, but this is not widely implemented. Depends on the devices that you have. It's not on Cisco Nexus. They at least at the time, those devices didn't support it. So we had a problem, and at the end of the day, Microsoft was like, well, you should use Windows Firewall to filter outbound DHCP, which, I mean, from a technical perspective, is crazy, and is from an operations perspective is as well. So you have to come up with like a decision in the space. But following this minimal machine approach, once you don't need DHCP, disable the service. Another thing that might fall into this category of disable what you don't need would be disable processing of local processing of router advertisements, which I'm going to discuss in a second. In this part of the talk, say the group of measures which fall in the category static configuration. What is usually done here, once you come up like, okay, this type of systems should get a static configuration, static set of parameters. But it usually means, okay, static addressing. There is some debate if actually this includes getting an address from, what about a default route, default gateway? Configure this in a static manner or get it by means of router advertisements. This actually can be combined. There is organizations who do this, give static addresses to servers, but those learn the HSRP address usually by means of router advertisements. This can be done, and I will discuss this in my other talk today when I discuss remote access, a specific setting. DNS resolvers usually is part of this set of parameter provisioning, and NTP servers. So far, so good. No, not much like difference to IPv4. Problem is, whereas in IPv4 you had a mutually exclusive approach, a system either had a set of configuration being assigned in a static manner, or a set of configuration acquired by means of DHCP. One or the other. In IPv6, those sets of parameters can easily exist in parallel. So if you really want to go with a static approach, this means at the same time you must disable all the dynamic stuff. Now it becomes quite tricky, and you will probably realize why I had these introductory notes on deviation from default and operations and so on, as disabling dynamic stuff. I want this system to have a certain set of addresses and to act in a predefined, well-expected way, which is, by the way, an illusion anyway. IPv6, there's so much things which do not really in a way that you expect or predict. You have to test your stuff anyway, and you have to expect surprises. I will get back to this at a later point. In any case, pursuing the road of doing something in a static manner means you have to disable the local processing of router advertisements. You have probably, once you want to do this in a consistent manner, disable the local processing of redirects. And of course, as I already mentioned, this might include disable DHCP service, or maybe in some future point you can do so selectively for v4 versus v6. But in any case, I mean, in v4 you would have asked, well, I have a static addressing. I can let a DHCP v6 DHCP service running. You wouldn't have cared. You wouldn't even have noticed. In v6, you must disable this one explicitly, which is a good idea anyway, hardening, minimal machine, maybe. But again, this is about the main difference here being the provisioning systems, provisioning mechanisms not being mutually exclusive. When it comes to disabling the local processing of router advertisements, let me state a clear word of warning here. You really shouldn't do this. I mostly mention this, completeness sake, and as it's part of a certain configuration approach, which I discuss in this specific talk. But I can tell you, given my background in large-scale operations, you really don't want this. This is a severe deviation from default. The whole IPv6 universe is built around this concept of dynamic provisioning, dynamic, like, okay, I'm in this environment, this is the prefix, I ask the router for something. If there is some of you may know from the 80s, this German show, Berufe raten mit, Robert Lemke. And so you had to, for the non-German people in the room, you had to decide, you had to guess profession, the job of someone based on a set of questions. And the first question was, do you remember which one this was? Was hat Robert Lemke als erstes gesagt? Machen Sie eine typische Handbewegung. Please perform a movement that's typical for your job. Applying this to IPv6, you would ask, okay, what is a typical, a core packet of IPv6? And the answer would be route advertisement. In the middle of the universe, the most typical, most important, most core packet of IPv6 at all is a route advertisement. So disabling the processing of route advertisements essentially is like, okay, taking a car, remove the wheels, put it on a track, on a railway track. It might work, but it's probably against the whole way it is intended to work. So disabling router advertisements, be very, very, very careful with this. It might break functionality. And you should expect that once you recompile a kernel, once you install in Windows World a service pack, those are enabled again. As this is expected behavior of a stack to be able to disable to process router advertisements. This is probably the most severe deviation of default, which you can think of in the v6 world at all. So, after this word of warning, I'm aware that we are constantly facing this question and discussion in customer environments. So, for completeness sake, here's how it can be done. On Windows, well, there's the -h command on FreeBSD, which is what we run in our environment. We have been, most of our lives, we have been fans of BSD. We are pretty much everything we do is on BSD. You could do it, it's a syscontrol parameter, but on BSD there is a daemon, the RT-soldi, solicitation daemon, router solicitation daemon, responsible for actually sending router solicitations. If you don't invoke that, it won't happen, but the syscontrol is the most, prevents it anyway. On Linux, it's a POXSnet and so on. So one of the kernel IP stack parameters. Set this to 0 means don't process router advertisements. So it can be done actually. It's just we strongly recommend against this. Don't want to run a smooth IPv6 environment over a certain time. Again, keep in mind deviation of default. Changing a parameter is one thing. Keeping it in this state over the whole life cycle of a system, that it remains 0, even after touching system, after installing packages, after, again, kernel recompilation or service pack installation, and being able to like audit. How do I ensure that in a data center with a variety of operating systems, all the systems do not process route advertisements? That is an ugly, operations-wise, an ugly task. Can be done, but again, I recommend against this. When it comes to disabling redirects, which would be part of this approach, that is comparatively easy. Again, on Linux, it's one of the kernel v6 parameters. On Windows, it's a netsh command. But this one isn't in the core of the debate anyway. Third category I was discussing was like tuning, tweaking parameters. Is there anything that, on the IPv6 stack level can be tweaked to further strengthen the security posture? There is not much. There is two things we like to mention in this context. One is if you have to run MLD, go with MLD v2 only, as this is less acceptable to certain types of attacks. It's laid out how to do this in the, actually, I mean, I have it on the next slide too, but and the other thing that we usually recommend doing actually is, you might recall there is this RFC 6980, which essentially says once neighbor discovery packets, neighbor discovery as a broad term for everything that happens on a local link, NS, an A packet, RS, R packet, RA packets. Once those are received and are fragmented, as used in certain types of attacks, just drop them. That's what this RFC says. Obviously, this is a good approach, and this is a contribution of the local system. And in that area, the first of security, the network infrastructure cannot provide sufficient protection, which is by the host. The systems have to help, kind of, to do their part, which means, oh, wait a second. There's a packet which managed to sneak through the first of security on the switch. Looking at it, this doesn't sound, this doesn't look legit. Drop it. That's what RFC 6980 prescribes. I mentioned yesterday and repeated today. Unfortunately, this is not widely supported on OSs so far. The only main OS which has it is Linux, and there the default state is the right one anyway. So it's set on all variants and distributions we know. It's kernel versions. Once it's there, the default state is drop the stuff. You can you can configure this parameter as part of the kernel of the stack configuration, but you don't have to. On other systems, it might be like, say, once Microsoft comes up with this, they might decide to offer this, but not to enable it by default. Then it might be, it would be a good approach. Tweak this in a way that it actually happens. There is some more stuff like on the timing level, which we have laid out in the high. This is how MLD v2 is enforced on Linux. Fourth part, last part, local packet filtering. Again, I start with a word of warning. This should be like an ultima ratio approach. Once you don't have any ideas left and you come up with like, oh, in this specific segment there is a specific set of problems which we cannot counter by means of infrastructure levels. We cannot deploy for sub-security for operational reasons, or as the switches do not support it. And we cannot tweak, we cannot disable. The only thing we have left in our arsenal of tools would be like drop certain packets on the system level. Be very, very, very careful with this. Not just from an operations perspective, as this is potentially quite tedious to deploy for many systems, especially when those are, again, heterogeneous, like you have Windows, Linux, whatever, Solaris in your data center, you have different versions of those. Then it's not easy. I mean, centralized configuration of local packet filtering on a heterogeneous environment. This is still a holy grail people are searching for. It's replaced nowadays like by hypervisor level firewall, but those are infrastructure. In this talk, I explicitly take the perspective of I'm a guy being responsible for operating a server, and I'm in an environment I have to protect myself. You can do this by local packet filtering. This doesn't mean you shouldn't. Actually, we strongly recommend against trying to protect v6 by means of local packet filtering. For the simple reason, there are so many examples. The relevant mailing lists are full of those, where people shoot themselves in the foot by doing not like by overlooking something. And actually, it happened when we set up the Troopers network of this year. And you can probably you can safely assume that both Chris and I, and actually, I mean, he was doing this, and he has when it comes to v6. In the last years, he has even had more hands-on than I had, but I would cautiously say usually we know our stuff, we know what to do, and even people like us, it happened, deploy, overlook something in an ACL, and boom, infrastructure. Something went wrong. So v6 filtering on, say, not done in the infrastructure, but very close to the actual entity to be protected. Be very, very, very careful with that one. And operations-wise, it's a nightmare anyway. So I have included in the arsenal, we have Antonios has in this one. He has, I mean, when he wrote this, IPv6 tables was still the most common way to do it. I understand I'm not that much involved in Linux operations nowadays. NF tables might be the future, but you mentioned the v6. There is some. Yeah. Okay. That is a very valuable contribution then. We have laid out rule sets how to protect yourself from all the nasty things that can happen on the infrastructure level by means of IPv6 tables. It's in this document. Look at this. We have done the same for the Windows firewall here, but again, be careful what you do. But there's a high potential that you overlook something and things go in the wrong direction. So, yeah, when you actually decide, this is the last resort that I have. Look at these guides. Actually, there's an old RFC 4890, which, when it comes to ICMPv6, still it's good advice in there. They have two categories: what to filter in transit, what to filter on a local system, which types of ICMP. All these attacks, the main IPv6 attacks, are centered around ICMP, so filtering ICMP in a proper way is usually sufficient. Another recommendation from our side: use the local tools. Do not do this with additional tools, like bring Kaspersky, whatever, or local host firewall deployed by McAfee on a system to protect against IPv6 stuff, as you will see strange things there. We have seen this in customer environments, interactions of these like third-party entities with the local stack. There's even more potential for things going wrong. So if you really want to do this, and you've probably noted, we recommend against this. But if you want, use the locally available kind of integrated stuff for this. Which brings me to the overall conclusions. As stated before, usually IPv6 security should be done on the infrastructure level. There is good things that can be done, and from an operations perspective, you should be very, very careful touching actual systems. The thing that we see most widely discussed is going with the static approach. this has its own set of problems too. As I mentioned, you have to disable the dynamic stuff, which again, operations-wise, might be tedious and cumbersome. So before you do any of this, think about it. Thank you. That's it from my side. I think we are pretty much. I went a bit over time, so good that we gained a few minutes there. Questions? Yeah. No, I mean the. uh, let me phrase it like this. Do you want to comment on this? Okay, you don't mind me being a bit nasty here. The typical response from an ITF guy would be, "Oh, we don't care about operations. So we care about okay, I'm being nasty. The thing is, probably the answer would be, why would you want to do this? IPv6 is, as it is, a good thing. So it's in short, this is not discussed in any RFC. To the best of my knowledge, are you aware that in like 4861 or so, there's any section? I'm not aware. Yes, that is thanks. That is very diplomatic. That is a good approach anyway. Yeah.
Which ICMP messages might be disabled and which ones are bad ideas.
Yeah.
To some extent, I think that might cover.
Yeah, that is a good point. This is actually this one, 4890. And 4890 explicitly says, whatever you do filtering local traffic, do not touch an ARS RA. So this gives an indication, well, process the stuff. Don't interrupt it. I'm not aware of anything. Yeah. Anything else?